Hi, I'm Kaz Maslanka. I'm a mathematical visual poet. I'd like to give you some tools to access some mathematical visual poetry. This is a lecture that I gave in the summer of 2019 at the Los Angeles Center for Digital Art. It was done in conjunction with the second annual symposium that was sponsored by the Film and Video Poetry Society. It was titled Analog Sun, Digital Moon. The director, Jesse Russell Brooks, will introduce me, and then I'll give the lecture, and I hope you enjoy it.
Welcome, ladies and gentlemen, and thank you very much for coming out to the Los Angeles Center for Digital Art. My name is Jesse Brooks. I am the Managing Director of the Film and Video Poetry Symposium. Here at the Los Angeles Center for Digital Art, we presented a 30-day gallery exhibit titled Analog Sun, Digital Moon. In that exhibit, we featured 22 artists from around the world, and Maslanka was one of those artists. He is a practicing mathematical visual poet. Both of his works, Congenital Wisdom, as well as Newton's third rule of karmic warfare, are on display here at the gallery. If you haven't already seen it, I encourage you to check out both of those works as they hang on the east side of the gallery as you're exiting. Kaz will be presenting a workshop today titled, is this an introductory to understanding?
It's really, I'm going to provide some tools for to access those two pieces.
Absolutely. So Kaz is going to help us understand what mathematical visual poetry is. As he said, he's going to give us some tools so we can enter his work and understand some of the ideas that he is presenting. And maybe that's something we can learn to do on our own, or if we see some other artists, which there are not many, who are practicing this genre, we'll be able to understand and enter what they're presenting. We're going to go as long as we can without this fan, but I swear, as soon as I turned it off, the temperature jumped up by like 10 degrees. We'll turn the fan back on, and we're going to have to speak loud to be over it. Well,
that's
ladies
fine.
and gentlemen, Kaz Maslanka.
Thanks.
I'll do that right now.
So, yeah, I guess we would turn the... Can you cut the light too?
Yes.
Fantastic. Thanks. Yeah, that fan. We'll need the fan. Great. So, a little bit about myself. I make a living as an engineering consultant in aerospace, although I don't have an engineering degree. I have a Bachelor of Fine Arts in Sculpture, but I'm self-taught as an engineer and been doing it for 35 years. But I read a book called The Dancing Woolly Masters back in 1979, and it inspired me to take math and physics classes for fun. And that, as an artist, I started seeing ways that I could use math equations for poetry. So, as a little boy, I was very interested in electronics, and I got my ham radio license when I was 14, and I was totally enamored by the magic of radio, because a radio wave is powerful yet invisible. It travels at the speed of light. That's 7 times around the Earth in 1 second. It bounces off of the ionosphere 250 miles up in the air and bounces across. I just thought, wow, what a fascinating concept with radios. And then as I got older and got more interested in art, I started getting interested in painting, and I was fascinated with the surrealists and the mysteries of the mind, and which led to the mysteries of the universe. So this is me when I was about 18, and I was painting back in those days. I was actually painting sounds. I would listen to music, and I would see imagery in the music and paint that. It was a synesthetic sort of thing. So what I want to talk about today is just give you some tools to access the two pieces that are out front. and show how mathematics can be used for poetics and be fun. Also, I want to cover a little bit about visual poetics. And this talk will have 3 sections, one for each of the pieces, and then we're going to have a little workshop at the tail end where we can do some math poetry. So I don't know how many of you are familiar with Giovanni de Carico, who was a painter around the beginning of last century. He did a lot of paintings with these strange skies of yellow and green with these towers and a flag on them. Numerous paintings like this, all in a motif around Italian landscapes. I was in Baltimore. I think I was visiting at this time. I used to live in Baltimore, but one time I was living, and I noticed in the Inner Harbor there was this giant tower with a flag on the top of it. I said, "Oh my goodness, that looks just like a De Carico tower." So I said, I can take a photo of it and then take it into Photoshop and kind of turn it into a De Carico looking painting. So this equation, because it has a question mark and an equal sign, is asking a question. Is this conceptually De Carico times Baltimore, mathematically, or De Carico plus Baltimore? And those are interesting questions. A lot of people don't ask them. Most people just think plus. We're just adding things together. But what happens when you multiply concepts? So you get different results. Here's a piece. This is an icon of a NASCAR race car driver and his number on his car. This, of course, is an 8 ball from a pool game. So we have 8 plus 8, 16, 8 times 8, 64. So let's see if we can make some sense out of this. So when we do addition, we can see that you have this pie chart has 3 and 4 in it. So when you add 3 and 4 together, you get 7, and you can easily see how conceptually you can break these two concepts apart. Easy to break apart. But in multiplication, it gets a little trickier, because now you have 4 groups of 3 that are integrated with each other, and now it's 12. It's got much more magnitude, much more amplitude, and it's greater. So it's interesting. You can't break it apart. They're integrated together. You also can do 3 groups of 4 or 4 groups of 3. So let's look at the 8 plus 8, 16. So we have the concept of the race car, and we have the concept of the pool table, and we put them together, and we can easily see how we can pull them apart. And the number we get 16. Okay? Now if we multiply them together, now we get, instead of a race car, a rocket ship. The number 64, much more magnitude. And instead of easily seeing how the pool table and the race car ideas can be broken apart, you can see now they're integrated. You can't get them out. The pool table pockets are integrated into the structure of the rocket ship. So conceptually, we're mapping these ideas. And we're not using language, by the way. So we're going to get into that as well. So when we have the piece, we have 8 plus 8, 16. We can pull it apart. 8 times 8, 64 in the rocket ship. So I want to talk a little bit about metaphor, because what mathematical poetry, the poetic idea in mathematical poetry is metaphor. So we're going to talk about conceptual metaphor and cognitive science. These 2 cognitive scientists wrote a book called Where Mathematics Comes From, which talks about how mathematics is, much of mathematics is metaphorical at the very root level. So this is a great definition, and all of this stuff that I'm going to be talking about on this cognitive science stuff is George Lakoff mostly, who I find very inspiring. I didn't come up with any of this. Okay, so The mechanism by which the abstract is comprehended in terms of the concrete is called conceptual metaphor. Conceptual metaphor. Poetic metaphor, for the most part, is an extension of our everyday conventional system of metaphorical thought. So, let's talk about a conceptual domain. What's a conceptual domain? Conceptual domain is an idea or a concept where we can map on top of each other. So, each conceptual metaphor has the same structure. Each is a unidirectional mapping from entities in one conceptual domain to corresponding entities in another conceptual domain. As such, conceptual metaphors are part of our system of thought. This is very important. It's not language, thought. Their primary function is allow us to reason about relatively abstract domains using the inferential structure of relatively concrete domains. So we have a one-to-one mapping from the concrete, we're mapping onto the abstract. So conceptual metaphor, to illuminate the nomenclature, how Lakoff lays this out, and I know that he's was influenced by people before him as well, is to illuminate the nomenclature works for analyzing conceptual metaphor. Lakoff describes the process as metaphorical aspects of one concept, the target, are understood in terms of non-metaphorical aspects of another concept, the source. Target is source. But when we're mapping, it's really backwards. We're mapping the source onto the target. So, a metaphor with the name A is B is a mapping of part of the structure of our knowledge of the non-metaphorical source domain B onto target domain A. And in other words, when we map one domain to the next, we describe it in terms of mapping the source domain to the target domain. Using this nomenclature helps us to see the mathematics of how mathematical poems work. An example. Life is a journey. Okay? We are mapping the non-metaphorical aspects of journey onto the abstract metaphorical aspects of life. Or the metaphor, death is eternal sleep. We are mapping the non-metaphorical aspects of death onto the abstract metaphorical aspects of eternal sleep. This is how metaphors work. Metaphors in poetry, metaphors in RLR language. We're mapping one conceptual domain, a concrete domain, onto an abstract domain. And in mathematical poetry, we do the same thing. So how can mathematical equations be used as a conduit to carry poetic metaphor? And you can use about any type of structure to carry metaphor, not just math poems, but math poems provide a great structure to do that because we have a relationship within that structure, much like sentences and grammatical. So I put together a conduit of a recipe for an orange cake. So here's the recipe for an orange cake. 1 cup, 2 sticks unsalted butter, room temperature, plus more pans, 1.5 cups of flour, baking powder, baking soda, salt, orange zest, sugar, eggs. So we can see the ingredients here. And we're going to map one-to-one mapping across the conceptual domains using the recipe as a metaphor. So we got butter, slippery, slick. Flour, white. Baking powder, producing hot air. Baking soda, deceive with acidic nature. Salt, delaying decay. Orange zest, orange color. Sugar, sounding sweet to the ignorant. Eggs, to thicken the plot. And so I just put together this little iambic pentameter thing just to illustrate how you can use a recipe as a conduit for metaphor. The distaste of orange cake. He's a slippery, slick blowhard and a team player of the gooey white golden boy Omphaloskepis Denial Club. maybe the greatest of hot air vendors, filling balloons to ship the truths away, never to be seen by the meek again. For the heavier truths, a sleight of hand. He pours his spice rack of acids, melting into the fabric of his excuses. His salty nature binds to the thick schmaltz, obscuring and moronic humor for the insatiable white punk's rodeo. A rotund windmill in orange motif, singing sweet, sugary, pale lullabies to the insecure, homophobic racists. When you ask the gods the obvious, why, they whisper to you to thicken the plot. So here's we're using a cake recipe metaphorically to map a poem. So what is a mathematical paradigm poem? Because these are examples out in the lobby here of mathematical paradigm poems. So a mathematical paradigm poem is using a concrete model expressing some concepts based on the relationships of the elements to them. The model, a paradigm poem, is a concrete conceptual domain. So we're going to use that as the concrete domain that we're mapping onto the abstract metaphorical domains. The idea of nesting domains, we all know that we can have concepts within concepts within concepts that are all nested. So these would be nested conceptual domains. So roughly this is Newton's second law, force is equal to mass times acceleration. So in mathematical poetry, we map the non-metaphorical aspects of the math equation, or in this case, a paradigm model, onto the abstract metaphorical aspects of conceptual domain or domains. So here we have force is equal to mass multiplied by acceleration. So we're mapping a poem into that. So for the force, we say yesterday's freedom. So there's a force in that freedom. The mass is a lush clover patch, so you can feel the weight of this clover patch. And then the acceleration, the swelling is in accelerating, the swelling, sweet summer breeze traversing the morning. So here we're mapping these metaphorical aspects into mapping the equation, the concrete domain into the more metaphorical abstract domain. So since we're talking about Newton, we have our good buddy Isaac Newton here. That was his second law. We're going to talk about Newton's third law in karmic warfare. So this piece basically uses Newton's third law, which says for every action there's an equal and opposite reaction. One force equals another force. And then we're mapping a poetic expression into that equation, or really mapping the concrete onto the abstract. This is a Joseon Dynasty Korean karma mirror. We'll get into that here as well. So we're mapping karma is Newton's third law. So this is our mapping target to source. So in the context of this talk, we are mapping the abstract aspects of karma, what goes around comes around, onto the non-metaphorical aspects of Newton's third law of motion, using two forces that are equal to each other, or we could say two karmic forces. So here's a force, mass times acceleration, mass times acceleration. So Newton's first law basically says that an object will not change its motion unless it's acted upon by an unbalanced force. So if something's moving through space, it's going to continue moving until a force acts on it. And once a force acts on it, it's going to continue moving until another force acts on it. Of course, our experience was we have air, and that air provides friction against forces, so that slows things down. That's why your car, when you step on the car and go let it coast, it eventually slows down due to the friction in the wheels and air friction against the car. So Newton's second law of motion is the acceleration of an object is proportional to the applied force divided by the mass of the object. So we have acceleration is equal to force divided by mass. A while ago we saw force is equal to mass times acceleration. how many of you have not taken any algebra classes? Well, that's great. That's good. So I'm just going to give you a little refresher on solving an equation. So how do we get back to force is equal to mass times acceleration? So I explain it to people that don't know math is if I have a table with 2 apples and 3 oranges, a big equal sign, and another table with 3 oranges and 2 apples and 3 oranges. 3 apples, 2 oranges equals 2 apples and 3 oranges. If I pull an orange away from this table, now it's not equal. I got to pull another orange from this table to make it equal. Anything you do to one side of the equation, you have to do to the other. So if we multiply mass on both sides of this equation, because you got to do it to one side, you got to do it the other, then you get the mass divided by mass is 1. 1 times force is just force. So force would be mass times acceleration. So we can play with that with our poetry as well. Newton's third law basically is for every action there's an equal and the opposite reaction, which is what we're using in this other piece, which is the same thing as karma. What goes around comes around. So if we talk about mass is the amount of matter in an object. Mass is proportional to its weight. So as you feel it, you can feel the heaviness of that. Acceleration is the change in velocity per time. So we have the change in velocity per the change in time. When we accelerate your car, you step on the accelerator, we're changing the velocity per time on the accelerator. So here we're talking about force again. To move an object, you have to apply force, you have mass, and you accelerate that object with the force. So if we substitute acceleration with the change in velocity per the change in time, we get force equals mass times acceleration here. So there's an actual example of force on a real car. So we talked about this one already, but now you have a little bit a better idea of what force is, or at least if I may have just given you a refresher, you may have already known what this was. But so let's move into. So here we have momentum. Let's talk about the concept of momentum. While we're doing this, we can play with these ideas of force as well. Momentum is mass multiplied times velocity. Mass and velocity. Okay? So we can think of force in terms of momentum per time. Also, another way that we can think about that. So momentum is mass times the velocity. If I take 2 balls, one's made out of steel, one's made out of wood, and I toss them at you, which one's going to hurt the most? The one with the steel, because it has more mass. You're feeling that mass when it hits you. So, I don't know, have you ever played the egg toss game, where you toss an egg and you try to catch it and keep it from breaking? And then there's a game where you have like 2 teams, and there is maybe we'll say 5 people here and 5 people here, and all 5 of these people have an egg. They toss it to their friend catches the egg, and everybody does it, and then they take 2 steps back and do it again. Now it's more difficult. Now one of the persons is going to catch it and break the egg, right? Take 2 more steps back, do it again until you only have one couple left. That's the game. So the object of the game is to change the momentum of that egg from maximum to 0 over the greatest amount of time. So we're catching that egg. If you change it, force is changing momentum per time, right? So we're changing the momentum of that egg, mass times velocity. If the time is a short period of time, more force breaks the egg. So we're able to feel these when you get into the physics and understand how the language works, and when you use it poetically, the mappings make a lot more sense and they're more beautiful. So karma is Newton's third law. We kind of already talked about this. Newton's third law states for every action there's an equal and opposite reaction. In the vernacular, karma has been described as what goes around comes around. We're talking about the same sort of thing. From the perspective of mapping, we can say that Newton's third law mapping is a set of ontological correspondences that characterize epistemic correspondences by mapping knowledge that we have about karma onto knowledge that we have about Newton's third law. So, and this is the Lakoff's terminology, which I find fascinating. Although I'm looking at this now, and I think I might have it backwards actually, because we're mapping the concrete onto the abstract. I took his verbiage and mapped my idea into it. So Lakoff's idea is like, what does it mean? These are the interesting conversations that mathematical poetry brings up when you look at a mathematical poem. You should be asking questions. It should provoke questions so that we can talk about the aesthetics of thinking and analyzation. So Newton's third law, we just talked about how you all have seen Newton's cradle, where you have one force is equal to another. So we've pretty much covered this. Let's talk about a karma mirror. So these are Chinese paintings from a few hundred years ago. As you'll see in the paintings, the mythology states that when you die, you go into like a hell, and these demons pull up this karma mirror and show you your karma. You've been a bad boy. You've killed these animals. You're going to have to pay in your next life. So there's lots of these karma mirror paintings on the internet from China. The Los Angeles County Art Museum of Art over on Wilshire, has a Joseon Dynasty Korean karma mirror sculpture. This was the object that I used in my piece. So I basically did a digital painting of that piece. So we're mapping the concrete onto the abstract. So in the abstract, we're mapping for the mass, the change in velocity, the change in time is this force. This force is the mass, the change in velocity, the change in time. So for the mass on this one is the level of my self-righteousness, since I have a massive ego. The change in velocity is me taking life from you. The change in time is the time it takes for me to kill you. We're talking about karmic warfare. We're talking about war. On the other side, we have the mass is the level of your self-righteousness. The change in velocity is you taking life from me. The change in time is the time it takes for you to kill me. So we have equal forces in karma. These eyes in here, they look like a painting when you get close, but when you get back further away, they're actually my eyes superposed into it. So there's some pretty bad karma in here. We have an atomic explosion at Bikini Atoll. You can see these German ships that get sucked up in it. When I was studying this, I thought, well, this is really fascinating that the Orientals came up with this idea of karma being a reflection of action and a mirror reflection of image. And then as I was studying it, I was noticing that the equal sign was a reflection of value. And I thought, well, that's interesting. It all ties together. So I put in here mirror equals karma to help kind of tie all these concepts together. So we didn't talk much about the visual poetic aspects. I think most of you are really visual people and are probably pretty familiar with a lot of the things historically with visual poetry. Guillaume Apollinaire did these collagramms where the poem and the image were tied together. He was influenced the Surrealists, who were very much into poetic ideas. Back to De Carico again, who didn't, I don't know that he consciously thought about poetic ideas, but he certainly inspired René Magritte, who did think about those sort of things. But we'll get to René here in a second. So let's reiterate. This is a quote by Lakoff. The generalizations governing poetic metaphorical expressions are not in language, but in thought. They are general mappings across conceptual domains. Okay, we all think metaphors are part of language. Lakoff is basically telling us that no, it's based in thought, and you can see that in the work of René Magritte, because while he's using language here, he's using a conceptual thought here. So we have an acacia tree, an egg, the moon, a shoe, the ceiling, a burning candle, the snow, a black hat, the tempest, a glass, the desert, and a hammer. So the key to dreams. So this disjunct metaphorical aspects of dreaming that the Surrealists were very interested in, and we all are aware of dreams and metaphor, probably more so today. So this is one of my favorite Magritte paintings. This is the illustrious youth. You can see these metaphors on the path of the youth. Again, not language, but conceptual domains. One of my more favorite pieces, The Castle in the Pyrenees. That really had a impact on me the first time I saw that when I was a youth. In America, there was a concrete poetry movement. It also occurred in South America. This is one of Carl Kempton's pieces. He tells me, of course, this is visual poetry. Carl has written a great book providing the history of visual poetry from ancient times to the modern. It's a great book. This piece is called Jump, Skip, Flip, Leap. You can see J-U-M-P, S-K-I-P, F-L-I-P, and L-E-A-P. Based in it. This is a little visual poetry thing that I put together in a panic. Why did I do it? So all of the text in here, all of this imagery is text of why did I do it. So I think we want to take a little break, maybe 5 minutes, and then we'll get into the next piece, Congenital Wisdom.